All right. So 15E. All right. Says that. Okay. So first of all, the problem is saying in sports such as tennis, players often think it makes a difference which side of the court they are on. Suppose that in a particular match, Kathy wins 22 of the 37 points when facing away from the sun, but only 11 of the 35 points when facing the sun. Do these data give convincing evidence that Kathy plays better than not facing the sun? You have to go through that, you have to calculate the test statistic, you have to make a graph, you have to state the hypotheses, you have to describe how to set up that simulation using note cards, and then you get to part E, where it says, suppose that the results of the simulation gave a p-value of 0.01 in terms of this value. Okay. So it tells us that our p-value is equal to 0.01. Right. So my first question would be 0.01. That p-value, what percent would that be? Would be equal to 1%. Okay. So here's what I'm going to tell you. All right. And I've been so this is my first time teaching these classes. When I was first explaining this, I was using exactly what the book would say for its explanation of what the p-value is. Right? And as I've been talking to people more about it, as I've been helping other students with this, I've come up with a way to describe what the p-value is better. Right? So to give you a better description, better definition of what it is. Right? So p-value right, it first and foremost is a percentage. Okay? It is a percentage. I don't know what P stands for. I don't think it stands for it now. I didn't Google it. It doesn't. Can't find out what P stands for. All right. So it is a percentage. All right. And what that percentage describes is a percentage that describes the number of your, or it doesn't describe the number. It describes that baby, right? No, well, we're going to use this answer. It is a percentage that describes the percent of simulations where the test where the simulation where the simulated test difference is higher than the actual test. Okay. You don't have no as you're leaving the house, all right. So it says interpret the value. It tells us that our p-value is 0.01, which is 1%. So it is a percentage. All right? So how do we interpret this? Hello? Yep. Uh-huh. Yeah. All right. Yeah, the first one is on the board today. Okay. Cool. All right. So, what does the p-value describe? The p-value describes the percent of simulation where the simulated test difference was higher than the actual test difference. All right. So, you have homework? Shoot it up. Okay. So, what does this p-value describe, or how can we interpret this? Well, we can interpret this as 1% of our simulations had a difference of what was the test difference for that problem was for test was 28.1%. Had a difference of 28.1% or higher when observing when so yeah when difference of 28.1% or higher when facing away from the sun and facing away from the sun. Alright? And the important thing to remember here when you're saying this is that these simulations occurred due to random chance. So this percentage, alright, is 1%, but that's occurring due to random chance. Okay? And so, again, the interpretation, basically interpreting the p-value is telling us what percent of our simulations were either equal to or greater than, in this case, greater than our test. Alright? So, if we go look, we say 19 is a little bit different, I believe. It says, so I'm going to read the first part of the example. In an example in this chapter, we compared the 2009 performances of the Yankees pitcher A.J. Burnett with Jose Molina was his catcher and Jorge Posada was his catcher using an opponent's batting average. Critics of manager Joe Girardi's decision to play Molina pointed out that he is a poorer hitter than Posada. This is true. The hitting performances of these two catchers during the 2009 regular season are summarized in the table below. So you had to construct the graph using that two-way table. You had to state the hypotheses. We had to figure out what the test statistic was by finding out the batting average or the hitting percentage of each player and subtracting them. And then we had to describe how to set up the simulation. Then part E asks, a 100 trial simulation was conducted, assuming that Molina and Posada have the same ability to get a hit. And the difference in the batting average, Posada minus Molina, was calculated for each trial. The results are shown in the dot plot below. Based on these results, what would be an appropriate conclusion? So, let me actually pull this dot plot up on the on the computer real quick, so that way we can actually look at it and talk about it. All right. So that's the dot plot that we're looking at in 19. Okay, and in order to be able to draw any conclusions, we need to know. Well, first, in order to start, the first thing we need to know the test statistics. And second thing we need is we need to use the test statistic to find p-value. Alright. So, in part C, you had to actually find the value of the test statistic. Anyone have what that was? 6.7. Okay. I got. What did you do? You do 28.5 minus 1.7. Well, I didn't know. Well, I know, but you did 28. You did 28. Something minus 1.7. Right. So, what I did here was. I did the tests. So you see how it asks in the question, it says, decision when Molina was, we're trying to figure out if Molina's batting average was 4, right? So what we're gonna do is Molina, and what does it say? You might be right, yeah. So it says, it does say Posada minus Molina in the prop. It says, the difference in batting average Posada minus Molina was calculated for each trial. So the one is, what did you get? You said 6 point what? 6.7. So our test statistic was 6.7%. All right. Now, if we look up here, are these written as percentages or are these written as decimals? So, how would we write 6.7 as a decimal? Or more. 0.067. Alright, so we know our test statistic. Now, we want to figure out what our p-value is. Now, think about what we just said. Our p-value is the percent of simulations where the simulated test difference is higher than the actual test difference.
Pardon the interruption. Every time, the mobile unit will be taking no more sports physical appointments. If you have any paperwork, please return it into the office. At this time, the mobile unit will be doing no more sports physical appointments. Again, if you have paperwork, just bring it into the office. Thank you.
All right, so the p-value is the percent of points that are higher than 0.067. So a percent is it's something out of something, right? Something out of the total number. So what first we have to do is we have to locate 0.067 on our dot plot, right? So where is 0.067 higher than 0.05? Yeah. So it looks like it's going 0.05, 0.06, 0.07, 0.08, 0.09, and we got 0.1. So we have 0.05 right here. This is 0.06 right here. All right. So 0.067 is like probably right now, right here before 0.7 or 0.07. So we need to figure out what percent of our dots are equal to or higher than 0.067. So the percent is going to be number of dots that are greater than or equal to 0.067 divided by the total. Okay? Well, first of all, how many, what is the total number of dots we have? In this graph. Each one of these dots represents a simulation. How many simulations are in this problem? 100 says there's 100 simulations. So we're going to divide by 100. Alright? Now, it says number of dots greater than or equal to 0.067. Alright? So we have, we're looking at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of 100. What percent is that? 10%, because it's equal to 0.10, which would be 10%. So this is 10% is our p-value. Okay. So what we then need to do is we need to look at, remember those guidelines for drawing conclusions, right? The first one we said, okay. So first, we have a p-value of 10%. The first conclusion was p-value is less than 1%. Is our p-value less than 1%? No. The second one was, remember, p-value was, well, it was between two numbers. What were they? 1% and 5%. Is 10% between 1% and 5%? No. And then the final one said that our p-value was what? Greater than what? Greater than or equal to 5%. So our p-value is greater than or equal to 5%. It's greater than 5%. So we know that we're using this guideline. Now what did that guideline say? So our conclusion would be, remember? So are we going to reject or fail to reject our null hypothesis? Okay. So our conclusion, we fail to reject our null hypothesis because there is not convincing evidence to support what? Our alternative hypothesis. That's part needed. And the final step, the p-value, which is a percent, so you count the number of dots that are greater than or equal to whatever the test statistic was, and then divide by the total amount, which is percent. And then you use those three guidelines to figure that out. So, okay, that's a good question. Let's look at that real quick. Yeah. All these questions essentially do the same thing. You're going to get more practice today, you have more problems out of you. Alright. So Jason, your question was a good one. He asked, how do you get the test statistic? Okay, so in this problem, Jason, it does have a two-way table. What it says is Marina, Sada, total, you have hits, outs, total, you have 30, 109, 139, 108, 274, 382, and then 138, 3, Alright, so it's asking us, what is the test statistic, assuming that Marina and Masada have the same ability to hit. Alright, so Marina and Masada, what they do, so first off, the test statistic is the difference between the percentage of successes. Percentage of successes in this case is hits. If the hit is successful or not, it's not successful. So, one of the percent of times they get a hit, I would go like that. So, for Molina, the percent of time that he gets a hit would be 30 divided by 138. Right? And then, Barbara, did you get that? Or, for 81? I'm not sure.
No, that's wrong.
I just know the answer for 19.
Oh,
91.7. 12.7? Right. There's Molina, and then you know Posada. That's going to be 109 divided by 383. That's equal to what? 28.4. Okay, and then what I'm going to do is I'm going to take Posada, subtract it to Molina, or Posada minus Molina, so it's going to be 28.4 minus 21.7. Don't matter. We can do it. So it says 20.4 minus 21.7, so what's that going to be? 6.7%. So Jason, that would be your test statistic. Now, to do a graph real quick, this is stuff, so I'll just do it here. So do 5, 10, 15, 20, 25, 30. We're going to have Molina, Posada, hit. So 21.7, 5, 10, 15, 21.7, and there. And 108.4 is going to be like.
How do you take the
So after that, so we find the test statistic, we're going to go to our dot plot. We're going to locate our test statistic on the dot plot. We said 6.7% is equal to 0.067. The reason we did that is because we saw that these are percents. It's open. These are percents. Those are Alright, so 0.067, find that, so I'm going to 0.05 here, 0.06 is here, so this is 0.067 right here. So then I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 out of the 100 dots fall above or at my test.
Okay, so you come from our baseline setting.
Yeah, you count from wherever you get, you count from wherever your test statistic is, and then you count that one that are higher than it. Questions about that? Alright, so what I need you guys to do now. Okay. So now, if you're done with that homework, alright, I want you to turn that in. Okay? Now, I said earlier, so hold on to that when you put it, because I don't get another one today. You good? So the work that you're going to do today is nearly identical. Alright? So what I need you to do is, I did not print it out this time. You're going to type your answers. Right? Type your answers.
Are we writing that right now?
On the iPad. Yeah. No. These are new problems. And you can put the graph, you need to put a graph in there. It's easy enough to put a graph in there. You guys have done that. I can also help you show you how to put a graph in on the iPad. Alright, but I'm gonna have you, I wanna try this. So I need each of you guys to log into that, iPad now, and then go to Google Classroom, log in with your ID, remember, your student ID at columbus.paypro.oh.us, I'll put it over here. So it's ID at Columbus. Jpro.oh.us, and then it's your birthday. For the other one. Well, if someone's logged in, you have to switch it to on. Now, as I was saying, I would do, if it involves math, I would do the math on a section paper and then we take the math on. Actually, what we could do is if you want, if there's math, you want to do math on there, you could take a picture of your work on the next two paper. Take a picture of it. Google Classroom. What are you doing today? Hold on, actually. Well, which one? Maybe birthday, I'm not that one. Sure. Maybe birthday. I think you guys calculators. And you see, there's three problems there. What I did is I put, you see we have all the problems, and then you're going to have these boxes with like A, and you put type in A in it.
Who's not making graphics? So that
I'm gonna work on. I haven't done number one. And then the other one, how do you make that? You're not putting that in the farm. So, actually, pause this. How do you make the graph? Not, it said, use the